So your exam is tomorrow. Very briefly, you should know the structure of your exams already by this point in time, but I can tell you specifically you're looking at, again, 75% of the exam is multiple choice numerical response. I do not mean 75% of the exam questions. I don't mean 75% of the time you're going to be spending. I mean the weighting is 75%. So whatever you get on that section of the exam is weighted at 75%. And the written response, Jack, can you open up your books, please? And the remaining 25% is written response. The written response, of course, is always one question broken into two parts, something worth 2 marks and something worth 3 marks. Just to let you know, this unit in trigonometry breaks down essentially into 2 broad topics. One is coordinate trigonometry, the whole XYR thing. One is triangle trigonometry, the sine and cosine law. And I think the coordinate trigonometry at this level is more important for written response. I guess I'm in fact coming out and telling you the written response will have to do with coordinate trigonometry, whether it's trigonometric ratios on the grid or solving trigonometric equations on the grid, something like that. Okay? I'm not going to give you sine law and cosine law problems as a written response. That's just putting numbers into a formula and calculating an answer. I can't tell you exactly how many multiple choice numerical response there are, but again, remember that this section is usually about 2/3, 1/3 split. So if there are 18 questions in that section, about 12 of them would likely be multiple choice, and the other 6 would be numerical response. Okay. All right, let's get to it. I'm hoping that you have questions that I can help you with. Any questions from this handout you would like me to go over? Go ahead. Numerical response 1? Okay. So we want to determine a reference angle if we have a rotation angle that's negative 740 degrees. And I know that you know what a reference angle is. It's when you draw the terminal arm, what's the angle between that terminal arm and the x-axis? The thing that makes this question difficult, everybody, is that angle of negative 740 degrees. So one way or another, we have to draw 740 degrees in a negative direction, tracking where we're at in terms of the angle. What I mean by that is a negative rotation angle is found by rotating that arm clockwise. So here's a strategy that I think will be helpful. We know where the 90-degree chunks are, right? Like, if I said rotate it 90 degrees clockwise, which is in a negative direction, that would be to there. If I said rotate it 180 degrees, that's 2 90-degree chunks. That's 1, 2. So let's start by figuring out how many 90-degree chunks 740 degrees is. Let's just start with that. And all I'm going to do is take 740 divided by 90. There are other ways to do this, and I'm just curious, how many of you know that the answer is 20 degrees just by looking at it? Yeah, so, and if you don't, that's fine, but I'll tell you what myself and some of those other people are probably thinking. So I divide that by 90, and I get 8 point something. Let's not worry about the 0.222. It's 8 90-degree chunks. So, and some left over, right? So if I were to count off 8 90-degree chunks, there's 1, 2, 3, 4, 5, 6, 7, 8. Now the question is, forgetting about that 0.22, how many degrees have we rotated so far? And we could go back to the beginning and start going 90, 180, 270, 360, 450. We could do it that way. Or we could say that if we rotated 8 of them, then we're at 720 degrees. Bless you. So how many more degrees do we have to go? 20. And that means the reference angle is going to be 20. Now, so if I were to draw this, this is what it looks like. That's what it actually looks like, right? You don't just do that and go around to it. I wanted to make sure I was going clockwise. How many of you who knew it was 20 knew that because you know 720 takes you back to the beginning? Yeah, 720 is 2 full revolutions. So 720 is just back to the beginning. How many more degrees do we have to go? 20 degrees. Does that make sense? Okay. Other questions? Really, let's have our exam today then. Some people are going yes, some people are going no. No, we're not having our exam today. But really, there are no other questions? Go ahead. 15? Okay, let's take a look at number 15. This is a dirty question. I mean dirty as in it's almost unfair. So we have a triangle. What's going on here? So we have a triangle in which we know 2 sides, and there's an angle that we want to find the maximum angle in this triangle, which seems, this question seems bizarre. It seems like, well, what do you mean maximum angle? Well, I'm going to draw it. Let's just start by drawing a triangle where we have, I think what I'm going to do, I'm going to try to draw it like the ambiguous case of the sine law, where I'm going to say that this is 11, and we might have to play around with the angle here. I'll see how it goes in a second. But that's side DE, so that's side F, right? I think we will have to play around with the angle. And then EF is 9. Let's put the 9 here. So I'm going to change this. I'm going to put the 11 here, which is actually how we would set it up with the ambiguous case of the sine law. Now, it turns out that this is the angle that we're trying to identify. And I'm going to take this to an extreme here, Sasha. If I were to make this angle right here 89 degrees, we don't know the length of this side, right? This is unknown on the bottom. But if I were to make that angle 89 degrees, then that length of 11 would be almost vertical. And that length of 9 would have no hope of joining the bottom of this to produce a triangle. So we know that this angle D can't be any value. And if I gave this question to you on an exam, I think I would give you this picture. I think it would be too unfair not to. Okay. So there's definitely an angle here, theta, or D, where D is too large to get a triangle. You know, on the other hand, I think you can see that if I made angle D 1 degree, it would be possible to take that length of 9 and connect it with the base of that to form a triangle. It's more than long enough. So the question is, what's the biggest angle? The biggest angle is going to be the angle where this is just long enough to touch there. So if this is 9, that's the largest angle that we can have for D, because if you go any larger, that 9 that's hanging straight down vertically wouldn't form a triangle because it wouldn't be able to touch the bottom. Does that make sense? So now what we're trying to do is find this angle in this triangle. And we can use just run-of-the-mill SOHCAHTOA here. You could use the sine law because the sine law works for any triangle, but I'm going to use SOHCAHTOA. That 9 in green is opposite angle D. And the 11 is the hypotenuse, so to find angle D, we're going to go inverse sine of 9 over 11. And I think it was right at the end of the class, after we had shut down, that Ashlyn and I were working on this question. And she had a really good point. But I want to talk about it just because you might encounter it in this class or other exams or math classes. If you take the inverse sine of 9 over 11, you get 54.9 degrees. So 54.9 degrees is the biggest angle, right? But when you look at the answer is it A? Which says 55 degrees. And Ashlyn's point was 55 degrees is not the biggest angle. That's too big, isn't it? It's too big. It's actually 54.90 something. And even if you round that up a little bit, it's not the biggest angle because it's too big. And technically, if you round it down, it's not the biggest angle. It's too small. So really, this is kind of like saying, what's the square root of 2 equal to? And the answer is root 2. What's the biggest angle? The biggest angle is the inverse sine of 9 over 11. If you want to get really picky, that's the biggest angle. That's the only way you can write it. But I said to her, and I'll say to you guys as well, first of all, I don't think this question would make it on an exam, but the idea of the rounding here is what I want to talk about. I would say to you, round it to the nearest tenth. And then you don't overthink it. You don't go, wow, but if I round up, it's wrong, or if I round down, it's wrong, because I've given you permission to round to the nearest tenth. Do you get my drift there? Okay. Anyway, it's a very messy question, and then we have that other thing that we have to deal with, which is how do you round it? Because it doesn't say rounded. Okay. Other questions? Okay, so I need to know something here as a teacher so that I can help you out as best I can. And I'm just trying to figure out why there aren't any questions. And it could be that you just don't have any questions, or it could be that you didn't do many of the questions. How many of you have completed that handout? Oh, okay. How many of you have completed approximately half of the handout? Or more? How many of you have completed at least half? Oh, okay. So you still have work to do. That's fine. That's what we're going to do then. I would have been willing to stand up here and go over as many questions as you have, but that's what we'll do. And that's not a criticism. If you still need time to work on this, that's what we're here for. So get to work on it. I'm going to just take my attendance again, just to make sure, because I think I missed somebody, maybe not. And then I will come around and I will help you out. Okay? You'll notice that what you're looking at up here is a little bit different from your number 6. And I had this conversation with somebody at the end of Friday's class, or whenever that was, that it should be root 2 over 2. So that's the first thing, is there was an error in the question. It should be root 2 over 2. Now let's imagine for a second that it just said the sine of an angle is negative root 2 over 2. Okay? And it said the angle is in quadrant 4. And you were asked, this is something that will be required of you on tomorrow's exam, solving an equation. So how do you solve an equation? Your first step is to find the reference angle by, in this case, taking the inverse sine, and I'm really not sure why I wrote root 2 over 3, is to take the inverse sine of that number without the negative. So the inverse sine of the square root of 2 over 2. So inverse sine of the square root of 2 over 2. And we need to close the brackets on the first two. And we get 45 degrees. So the reference angle here for this rotation angle is 45 degrees. And it's in quadrant 4. So everybody, at this point in time, normally what you would do is you would eyeball, this is your eyeball, you would eyeball that negative, and you would say, oh, sine is negative, and sine is negative in the quadrants where y is negative. So you would normally then say that it could be a 45-degree reference angle in quadrant 3, or it could be a 45-degree reference angle in quadrant 4. That's what you would normally do. And then you would get two answers. One of your answers would be whatever this is, and one of your answers would be whatever this is. Okay? Except in this question it says it's not in quadrant 3, it's in quadrant 4. So we're not interested in this. We're interested in this rotation angle. And I can see, I think you've already calculated it. You're going to take 360 minus 45 and get what? 315. So we get the rotation angle is 315 degrees. Okay, but that wasn't the question. This right here was not the question. It was sine of b plus 80. But what we've essentially found here is that this angle has to be 315 degrees. Right? We changed it to theta, but that angle has to be 315 degrees. So what number would we add to 80 to get 315? And I say 135. No. 235. So we're kind of doing a little bit of a substitution here. We're saying, if you're looking for a nice algebraic way to do this, what you're doing is you're saying, let's let theta equals b plus 80. So we solve for theta, and then since theta equals b plus 80, we can put this theta in here and have 315 equals b plus 80 and solve it. That other part that I spent a lot of time talking about, the quadrant 3 and 4 thing, that's not really relevant. Well, it's relevant, but it wasn't the big deal with this question. Is that okay? All right, so this is numerical response 7. It says somebody is in charge of a ship and they see a lighthouse due north of where they are. So this is the lighthouse. And this is where the ship is. And it's due north, which means when you look on a map, it's towards the top of the map. They sail west. So when you look at a map, like a map of Canada, this ought to be good. There's Hudson's Bay, there's Newfoundland, PEI, Quebec, Ontario. That's not bad. Vancouver Island. It's Canada, right? The west is to the left. So the ship sails west. How far? 4.7 kilometers. And now they're here. So this, what's important, I guess, here is that this forms a right angle. And it says that the angle between the ship's path, so this is the ship's path, and the line of sight to the lighthouse is 42.1 degrees. And the fact here, Lily and everybody, that this is what it ends up being is kind of disappointing, and I'm going to change this question for the next time I use this package, because this isn't even then a Math 20 question. It's a Math 10 question. It's a SOHCAHTOA question. You don't even need the sine law or the cosine law. It says the distance from the ship to the lighthouse, so what we're trying to do is find this distance here. It's also, everybody, open to interpretation. I interpret this to mean the distance from where the ship is now to the lighthouse, not the distance from where the ship was to the lighthouse. But I'm going to work on this with you right now. We're going to get an answer and make sure that it's correct. It's pretty good, isn't it? Remembered my grade 6 geography there. We're trying to find this, which is called the hypotenuse. And in relation to that angle, that angle is right next to the 4.7. So the 4.7 is adjacent. So we can use cosine. Cosine of the 42.1 degrees is equal to adjacent, which is 4.7 over the hypotenuse. Let's just call it h for hypotenuse. This is actually a good question to practice a little bit of algebra here. We want to cross multiply or multiply both sides by h to get h multiplied by cos 42.1 degrees equals 4.7. And don't forget, Lily, that's just a number. Your calculator will get that number for us, but it's just a number. This equation right now that you're looking at is no different than me saying 7h equals 10. Right? It's really the same idea. You would divide both sides by 7. So here we're going to divide both sides by cos of 42.1. And, you know, when I made a big deal about saying that cos of 42.1 is just a number, let me back up and emphasize, I don't care what that number is. I don't want to find it. I could find it. But I don't care about that. I care about what 4.7 divided by that is. So we can just walk right into the calculation here. 4.7 over cosine of 42.1 gives me 6.3. So now I'm going to find out if my interpretation of the question was right. And I know as a teacher, it's a mistake to give you a handout that somebody else made. I should have made this myself, but sometimes I'm busy. Is that what they say the answer is? Okay, so my interpretation is right. I would, if this were on an exam and it wouldn't be on a 20-1 exam, I would definitely make it clear by saying the distance from the current location of the ship to the lighthouse. But does that help? Okay, good. You still doing okay? Good. How about you? You good? still good? Okay, good. How about you? Yeah? You still doing okay? Okay, good. And how are you doing? Good? Jasmine, are you still right? Okay. Declan, any questions? You're good? Lucas? How's it going, Zoe? Certainly. Numerical response, is that a... can't read that. 9? Okay. What makes this question difficult, I believe, is that you don't have a triangle to look at. Getting the triangle is going to be what's going to put us over the edge and allow us to find the answer. So we have PQR, and here's what you can always do. Well, I'm going to say here's what you can always do as long as it's not going to be the ambiguous case of the sine law. Draw any triangle you want, label it PQR. It may not look right. The sides may be drawn wrong in terms of lengths, but it doesn't matter because we're going to use a formula. So PQR. This is P, this is Q, and this is R. This is our goal. Because the question says, what is angle P? So what do we know? Side P is 5. Side P is always opposite or across from angle P. Side R is 6.5. So you know what? I kind of lucked out so far because 5 and 6.5 are kind of close to the same thing, and the two sides look kind of close. But you know, this one should be a little bit longer. But you get my drift that it doesn't really matter. Okay. And angle Q is 35 degrees. Well, that's a lot more than 35 degrees, but it doesn't matter. In order for us to find this angle, we need something else. Now, can we use the sine law? Let's approach this logically, like from a troubleshooting standpoint. There's a problem here. How can we solve it? Can I use the sine law? No, because I don't know an angle side pair. So that means the only tool I have at my disposal is the cosine law. And I can use the cosine law to determine the length of this side, because whenever you know two sides and the angle between them, that is the cosine law for finding the third side. So let's start with that. In this particular case, I'm just going to need a little more room. We can write that side Q squared equals 6.5 squared plus 5 squared minus 2 times 6.5 times 5. I'm going to run out of room times the cosine of 35 degrees. Does that make sense how I set up the cosine law there, Zoe? Okay. So let's do a quick calculation. Whenever I have a long thing that I'm entering, I always like to just pause and look at it before I hit enter. Well, sometimes I forget to and I make a mistake, so it's important to double check. But I think it looks okay. I'm already in degrees, so I'm fine. Be very careful here because the number you get, 14, seems like an answer that would be reasonable, but that's not that side. I still have to take the square root. So 3.74. Now, when you use your calculator, do you use the up arrow to grab previous answers? Okay. What I do, and I'm just mentioning this in case other people have a TI-83. I like the TI-83. Is I store this. So I'm going to store, go STO, and I'm going to store it as Q. alpha and I locate Q, and there it is. Now it uses capital Q, but that doesn't matter. Anytime I want that number, all those values, I can grab it. Okay. So now what? How are we going to find, oh, well, now we know a pair, don't we? An angle side pair. And we know half of the pair for the angle we want to find. So essentially what I'm going to do here, everybody, is I'm going to use the cosine law with that pair to find half of that pair. So I can say sine of 35 over 3.75 equal to sine of p over 5. Sometimes this is no surprise. In fact, I was just talking to my math 30s about it last week, that the philosophy by the time you get to grade 12 math is that you're taught the concepts and then it's up to you to be able to apply them to things that you may not have thought of doing before. So in other words, you're going to see stuff on exams more and more that we don't necessarily see in class. But they rely on you being able to apply previous skills. So what do we have here? We have a coordinate grid, which is something that is kind of connected to this unit, but not really, not in terms of triangles directly. And we have a line segment AB, a line segment BC, and a line segment CA. We've got a triangle, and you're told two of the sides of the triangle and the angle between them. And the question is, what is the x-coordinate of point B? Now, there's a y-coordinate as well, but I really don't care about the x-coordinate. Sometimes, not often, but sometimes you're given a lot of distracting information. And really what this question boils down to is that this distance is the x-coordinate. Right? The x-coordinate is how far to the right of the origin point B is going to be. So really, if I take a look now at this question and what we need to do, you need to focus on this triangle and determine the length of the bottom part of that triangle. In other words, everything else is a distraction. That's what this question boils down to. So again, it's kind of like the question that we were doing before with the ship. It turns out just to be a right angle triangle, and you're going to use SOHCAHTOA to find that missing side. Does that make sense? Okay. There might have been a more complicated, roundabout way of finding the answer, but in the end, as I said, all of this other stuff is just a distraction. It's trying to camouflage what you really need to do. Let's get an answer though. Cosine of the angle, 49 degrees, will equal that x value over 6.7. When I cross multiply, I'll get x by itself. So the answer should be 4.4 in the key. Is it 4.4 in the key? Oh, the answer is A, right? Or, no, sorry, the answer is C. Yeah. We're not actually calculating the number, they're giving it to you with the uncalculated expression. So first of all, with question 14, I'll have to wait for my computer to catch up. With question 14, if you're asked to find the perimeter, then you need to know all three sides. Okay, no problem there. So we have, I don't know if you were following what I was doing before. I think it was Zoe had a question, and I said, let's just draw the triangle. Who cares how good it comes out? Let's do a little bit more care here. I want an angle of 40 degrees and an angle of 35 degrees. So this will be my 40. Let's put our labels on there. This is angle A. This is angle B. This must be angle C, which makes this distance side C, which is 15. Are you okay with the setup? Okay. So right out of the gate, we can determine this angle. 105. Those three angles have to add up to 180. Unless I'm mistaken, these two add up to 75, which gives me 105. Now, it sounds like you found a mistake that was made, right? I won't finish this question for you, but other people are listening right now. Give me a minute, Jack. Other people are listening. Since you know this side and this angle as a pair, you can use the sine law to find any other side. So I can use the sine law now with this angle to find this side. Then you've pretty much opened the door to find the third side using a number of different methods, and then you're going to add all three together. Is that okay? Jack? 22? Man, I just... So, I made a very important point here, Jack, with exam questions. Sometimes you're given information that's there to distract you away from the best way to get the answer. In other words, sometimes you're given information you don't need to get the solution. You're asked to determine the x-coordinate of point B. Well, the x-coordinate of point B is this distance here on the bottom. And we can construct a right-angled triangle that will allow us to find that distance. Are you okay from there?